Okay, so chapter 3 is two parallel lines cut by a transversal. And this should be review, but I figured I'd throw it in here anyway because it's going to be tested in geometry, but we'll see. So the concept of this, I think I dropped my marker back here earlier. Yeah. Sorry about that. Should have grabbed that before I started, but this concept is going to be two parallel lines that we know are parallel. So they're marked like that. And for the rest of the video, I won't be marking them like this, so it's less cluttered. But just know that when you see those, that means it's parallel. Then it's cut by another line called a transversal, which is just a fancy word for a tertiary line that cuts through two other lines. So this is a transversal, just a fancy name. And we're going to talk about the angle relationships in this thing, because there's something we'll find that always happens as long as these lines are parallel. But first, I'm going to have to give you some names for angles. Again, these are the tools I talked about earlier when filling out that two-table chart, like in Chapter 2. So first would be same-side interior lines, which are on the same side of the transversal, and they're on the inside of the parallel, in between the two parallel, and they are supplementary, so they add to 180 degrees. So something like this, and there's going to be two pairs for every diagram like this. I have one highlighted here, but the other one would be on this side, the other two angles on the inside. And it goes without saying, but if you're taking notes, you'll want to write this down. Then same side exterior. So these are on the same side of the transversal, and they're inside, sorry. They're inside and supplementary. So it's the same side thing, same side interior, just on the outside this time. Again, there's going to be two pairs, the ones I have highlighted, and then one here and here. Alternate interior. So these are on opposite sides of the transversal. They're inside and they're congruent. So like the same measure. And that would be one, and that would be one, the ones I have highlighted, and then there would be another one here and here. Alternate exterior. So these are on opposite sides of the transversal. They're outside of the two parallel lines, and they're congruent. So just like alternate interior, except they're on the outside this time, like that. Corresponding angles. So corresponding angles are on the same side of the transversal, and they're congruent. So it kind of looks like they just slide up this transversal into the next spot it fits, if that makes sense. So one will be inside, one will be outside, and you'll have four pairs. The one I have highlighted, then it would be these ones, and these ones, like that. Supplementary. So supplementary angles, I kind of went over before, but they're on, well, they don't have to be on opposite sides of the transverse, but it's just two angles that add to 180 degrees or pi radian. And then vertical angles. These ones are kind of important. They're opposite angles formed by an intersecting line, or by two intersecting lines is the technical definition. It just kind of looks like you flip it around. They're sitting one on top of the other. And this one doesn't have to be in the, well, I mean, none of these do, but if you've ever seen the Jamaican flag forms two pairs with those black lines. The two green would be vertical, and the two yellow would be vertical. So I'll give you a second if you want to pause and write all this stuff down, because you'll need to know all these angles and everything. before I erase it, and we'll get onto the angle relationships formed inside of just something odd happens when you have a diagram set up like this, and we'll show you here in a second. You give me a minute to erase this. Perfect. So I take out my book just to make sure I'm going to the right spot. Yep. So I'll take blue and red for this. If we set this diagram up like before, two parallel lines, and I'm not going to write out that these are parallel, just assume that they are. And we'll take a transversal like this. Now, we have 8 angles that are formed. 4 up here, 4 down here. So I am going to label them A, B, C, D, E, F, G, H, I think. So this will be A, B, C, D, E, F, G, H. Like that. I apologize, those should be capital. Let me fix that. A, B, C. So if we have this, I'm going to tell you, well, actually, first let's simplify this because they're going to be a bit, we can simplify this down a bit. So first, let's go to those vertical angles I told you about before. Well, the vertical angles are always congruent, so that means angle A and angle D will be congruent, so I'll replace D with A, and then same thing with B and C. So that would mean that C is congruent to B. Now, there are a couple ways of going to the next part here, but let's say, well, actually, let's simplify down here too. So E and H are going to be congruent because of vertical angles. So this is also E. And then again, F and G because of vertical angles. So we'll make this G. Now, if we remember the alternate interior angles are always congruent, that would mean that B and G are the same angle, they're the same measure, so we can replace all of our G's with B's, right? So that's now a B, and this G down here is also a B, because if G equals B, then I think it was transitive property. If G equals B, then, or if B equals G, then G equals B. And then again, if we take our alternate interior angles, A and E are going to be the same angle. So we can put an A there and an A there. So just like that, we've simplified this down to having only 2 angles. We have A's and B's. And with that, we can also, now that you have proved it mathematically, when just looking at it, you can look at this and say, well, there's an obtuse angle and an acute angle. So all of the obtuse angles are going to be the same and all of the acute angles will be the same. Right? So from here, sorry, let me see where I have us go next. Okay, so now that we have proved that, I'm going to have us, I did this a little bit out of order, but I'm going to have us practice those angles we did before. right? So all those names and everything we learned before, I'll give you a quick quiz on before we move on to something else. So if we draw our diagram like this, and then red pen, black pen, A, B. I don't know if you've seen that YouTube channel. He's pretty cool though. A, B, C, D, E, F, G, H. If you ever want to look into calculus, he has some good calculus content on there. He's really good at explaining that, but I digress. I'm going to have a couple questions for you. Get the black pen. And we'll say, so I'm going to ask you, what is the relationship? That's probably not how you spell relationship, but this is geometry, not English. I'll probably say that a couple hundred more times. What is the relationship between... So what is the relationship between A and E relationship between A and E, C and F, B and G, D and F, and G and A. So I'll give you a second to think about that. Okay, A and E. Well, A and E, it looks like you could just slide E up the transversal to A, so that is corresponding. Then C and F. Here's C and F, so they're on opposite sides of the transversal. They're both acute, so they're congruent, and they're inside, so that's going to be alternate interior. B and G. So here's B and here's G. So they're on opposite sides of the transversal. And they're on the outside of the parallel lines. So that is alternate exterior. D and F. So here's D and here's F. They're on the same side of the transversal. And they're on the inside. So this is same side interior. And then G and A, they're on the same side of the transversal, and they are on the outside of the parallel lines. So this is same side exterior. So hopefully you got all of that right. And now we'll move on to something else now that we have a firm grip on our angle types and that there are really only two kinds of angles, obtuse and acute. So, again, give me a second to erase all of this, and then we'll be going through something that's, not really self-explanatory, but kind of. So if we have our diagram again, like this, and transversal, like that. Okay. So what if I say that, I don't know, choose an angle, this. Right here is 60 degrees. So I want you to label every other point on this diagram knowing that this is 60 degrees. So think about it for a second. All right, so well, we know that this and this, we'll just call this angle x degrees. We know that 60 and x are going to be supplementary. So because I'm using degrees, they're going to add up to 180. Well, so if 60 plus x equals 180, up here, I know 60 plus x equals 180 like that. Well, then you can just solve this from here. So we know that 60 equals 180 minus x. Well, actually, I apologize. I mean, you can do that, but it's probably not the best way to do that. I got ahead of myself. We know that x equals 180 minus 60, like that. And that means that x equals 120. So that means I can plug 120 in there, like that. And now from here, you can prove this geometrically, and I challenge you to do so. But the other way to do this, and the much simpler way once you grasp the concept, is to go 120 is obtuse, 60 is acute. This is obtuse, so 120, that's acute, so 60. Obtuse, 120, acute, 60. Obtuse, 120, acute, 60. And that is your answer right there. So just simple subtraction, and you will get your answer for that. So let me give you a couple other practice problems here. I don't want to erase this whole thing and have to rewrite it again, because that'll just take too much time. So what if this right here is 108 degrees? What would everything else be? So, well, 180 minus 108 is 72, like that. And with that, you can fill everything else out. I'm not going to, just for the sake of time, but you get the point with that. And we'll do one more. What if this is 147 degrees, like that? That would mean that this is 33 degrees, because 180 minus 147 is 33. Okay. Now we're going to work on something else, a little different, but still shouldn't be too difficult. Is what if we had numbers instead of, or what if we had variables instead of numbers? So, for example, what if we had here 4x minus 2, like that, and we had here 10x. So your goal here is to solve for x. So first, understand that these are, this one would be the obtuse angle and this would be the acute angle. so that they're going to be equal to 180 degrees when added together. So if we add them together, 4x minus 2 plus 10x equals 180. And let me put those in parentheses so you can, better see where the angles would be. We have 4x minus 2 and 10x equals 180. So from there, this is just a matter of solving for x. So when we add these two together, we get 14x minus 2 equals 180. 14x equals 182. And I cannot do that in my head because I'm not that good. But we get x equals 13 when you divide 182 by 14. So from there, if we solve for x, but now we plug x back into our equation. Well, 13 times 4 is 52, and then minus 2 is just 50. Let me check, make sure I did that right. Yep. So we know that this is 50 degrees like that. And then down here, we know that 10 times 13 is just 130 degrees. Like that. So that would be how you solve something like this. All right, I have a couple more examples for you. Like this. Give me a second to erase. Okay. We have this angle here is 6x squared. Just 6x squared. And then down here is 7x squared. If I've done that correctly. I think so. No, I have not. I have terrible handwriting and terrible notes. This is just 6x minus 64, and then this is 7x squared. Again, I apologize for, I had a small space in the corner of the page. I was trying to write small, and I wrote too small. But we have 6x minus 64 and 7x squared. Right? No, I am not right. Here is 7x squared. I might reshoot this part. I've made so many mistakes. Again, I apologize. This is the final form of it. We have 6x minus 64 and 7x squared. So if you think about this for a second, pause the video, do whatever. Okay. Well, these are going to be these are alternate exterior angles. They're outside of the parallel, and they're on opposite sides of the transversal, which means they are going to be equal to each other. So I know that 6x minus 64 equals 7x squared like that. From there, we can just solve for x like normal. So we say 7x squared minus 6x plus 64 equals 0. When we bring everything over, right, we bring this over. This is negative. This is negative to begin with. We bring it over. It flips to positive. If that makes sense. I do math a little bit differently than what's taught standard, but it'll work. So we know that we have 7x squared minus 6x plus 64. If we work that out, you put it into your quadratic equation, complete the square, however you want to do it, or, just use the calculator program. I put on your calculator if you have it, and you will get x equals plus or minus 8 like that. But you cannot, as I mentioned before, in this level of geometry, we can't have negative x or negative angles. So we're going to take just x equals 8. And there's a name for this. I'm not quite sure what it is, but when one of the answers doesn't make sense, you take the other one. So it's something with a V, but regardless, from here we get x equals 8 is your answer. I'm not going to have you plug it in and do everything for this one. So let me erase all of this now. And then I think we're going to do one more practice problem, if I remember correctly. I can turn the page. Yep. Actually, I have two more for you. Lucky you. So we'll take two parallel lines. Take my word that these are parallel. Because I'm such an awesome drawer. Did it freehand. No. So we'll have, hopefully I can do this properly, but we'll have 10x plus 4. 4 right here. Actually, I apologize. Let me do that in red. We'll do 10x plus 4. And then the other one is negative 2x plus 40. Negative 2x plus 40. So, again, determine what angles these are, whether they're congruent or supplementary, and then try to solve for x. So I'll give you a second, pause the video. Okay. So these are going to be congruent because these are corresponding angles. You could just slide this up here. So we're going to set them equal to each other. Negative 2x plus 40 equals 10x plus 4, like that. Now, if we bring all the x's over, so we bring let's bring 2x over so that it's, it'll work either way, but we'll say 40 equals 12x plus 4, like that. And then we bring the 4 over, so when we bring it over, it goes negative. Don't know why I'm teaching you how to do equations, but we get 36 equals 12x, and then 36 into 12 equals 3. 3 equals x, like that. Now, if you plug 3 into all your stuff here, you get 30 plus 4. This here goes to 34 degrees. And then down here, negative 6 plus 40 equals 34. That's not right. What? Yeah, 34. I don't know what I was thinking, but that equals 34. So when you plug it in, it all works out if you wanted to check your work. Okay, and I have one more for you, and then chapter 4. Chapter 4's fun. If I erase this, so I don't have to waste more of your time. Okay, we have 3x plus 3 and 2x plus 2. So we'll say, actually I have to see, yeah, 3x plus 3 and 2x plus 2. Just like that. So now, are these going, you have to determine whether these are supplementary or complementary. Or they won't be complementary. Complementary means they add to 90 degrees or 1/2 pi radian. If these are supplementary or congruent, and then solve for x. So these are going to be supplementary. They add to 180 because they are one is obtuse, one is the acute angle, and there's only going to be 2 angles. So when we add these together, we get 180. So 2x plus 2 plus 3x plus 3 equals 180. Like that. And then from here, if we simplify this out a bit, we get 5x plus 5 equals 180. Then from here, we subtract 5. 5x equals 175. Right? When we bring the 5 over, it goes to negative. And then 75 over 5 is 35. Like that. So that means x equals 35. And with that is the end of Chapter 3, Parallel Lines Cut by a Transversal. Hopefully this was just review. But if not, I hope this helps. And Chapter 4. Chapter 4 is going to be fun. Chapter 4 was fun to make. I'm sure it'll be fun to teach. That is triangle congruency. And I mean, it's a long chapter, but I had fun. And really, Chapter 5 is fun too. All of triangles are fun. So, see you in the next one. Sound like a YouTuber.